Thanks, Madame President. Mr. President, ladies and gentlemen. Je m'excuse auprès de nos amis francophones. Mon français maintenant, c'est pas ma première langue, malheureusement. Alors, je vais présenter en anglais. For this presentation, we're going to talk about how to detect biological warfare agents in the field setting. As you know, as mentioned this morning, having a biosafety level lab tree costs millions and millions of dollars, and no government or country is able to afford it. So testing and diagnostics of the biological warfare agents is going to be looked at different angle. Why not go into the field, get some presumptive results before you send it back to a biosafety laboratory for information. Encore une fois, pour mes amis de francophones, n'hésitez pas à m'arrêter s'il y a un problème. Juste lever la main. So to start, we're going to give you an overview what is the Navy Environmental Preventive Medicine Unit. Actually, it falls under the Navy Marine Corps Public Health Center, which falls under the Bureau of Medicine, then the Department of Defense. So we are a military institution, and we are the leader of public health issues for all the military. So we provide the needs for the Navy in the field of preventive medicine, entomology, environmental health, industrial hygiene, and health promotion. We also support the forward deployed preventive medicine unit during humanitarian assistance and operational mission. So just remember, NAPMU means our lab at home. FDPMU is our lab in the field. I'm going to use a lot of abbreviations. So, NAPMU 2 is at home, FDPMU is our lab in the field. And the goal is to rapidly assess, prevent, and control health threat material operations. At the national level, we have 3 units. I belong to NAPMU 2 in Norfolk, Virginia. There is NAPMU 5 in San Diego, California, and then NAPMU 6 in Pearl Harbor, Hawaii. There's a number 7 is coming up, and it's going to be in Spain. Our lab team is composed of 5 components. We have the preventive medicine component, and it has a preventive medicine officer, 1 environmental health officer, and 2 PrevMed technicians. The chemical component, including the radiological components, subcomponents, it has 1 industrial hygiene officer, 2 PrevMed technicians, 1 biochemist that can be available as a remote and serve in the microbiology components. The microbiology component has 1 microbiologist, 1 medical lab tech, and 1 biochemist. The disease vector component has 1 entomologist and 1 PrevMed technician that can also support the logistics and the admin support model with another foreman. Foreman is basically like a medic. In terms of laboratory services, we provide public health investigation, including outbreak response, clinical diagnostics, general bacteriology, identification of bloodborne parasites, specialized PCR diagnostics, and detection of bioterrorism agents, which is the subject of this presentation. Now, we talked about it this morning. I'm going to stop for a while and give the difference between clinical lab and public health lab. This is a big difference in the States. In the US, if you're not a clinical lab accredited, certified, you are not allowed to process human samples. Meaning that your second one is COLA, Center of Laboratory Accreditation. These two agencies, they are responsible for accreditation of all the clinical labs. So this is those two, the accredited body that Maureen talked about this morning to have for the biosafety and biosecurity labs. Clinical lab use only FDA approved or Food and Drug Administration approved reagents. You cannot use any reagents for human testing. You cannot. And the results are used for treatment. As you know, any reagents in the market, before they can put in the market, must be brought to the FDA for approval before you can use it. It's against the law to use any reagents that is not approved by the FDA. You can go to jail for that. Public health, on the other hand, is not necessarily accredited for clinical aspect, but it can have a certification to do disease surveillance, and it can use also some non-FDA approved reagents, like we do for certain diseases in lab. We can make our own primers and probes and run them for disease surveillance only, and not for clinical use, to be used for treatment. Our lab is an accredited lab, and it can serve both functions. It can be a clinical lab, and it can be a public lab. Clinical lab, we use FDA approved reagents. That's a good sign to wake you up if you're sleeping. I think you can hear me, right? You can hear me, right? I don't need that. So this is very important, because when you go to the field, it's important for us, because in the US, the human citizen is very important. If you use a non-FDA approved reagent and something happened to that person, you go to jail. Period. There's no discussion. But for public health purposes, it's very important to know what's the agent responsible for the outbreak. This is my opinion, and I believe it. I don't care if it's FDA approved or no, but if I come on the field and I have my people dying of disease or getting sick of a disease, my goal is to know what's the agent responsible for the disease, so we can take preventive measures. Now, before we talk about the protocol for receiving samples, this is when you go to the field, this is the layout of the camp. I don't know if you can see well, but so here we have the RevMed and vector components. Those are 10, by the way. Those are 10. This is the camp. So we have RevMed and vector component. We have admin and logistics here. We have birding area for male, birding area for female. Basically, so this is where we sleep at night. We have the chemical component, or the chemical lab, and here we have the micro lab. And this small tent here, that's where we receive the samples. And the whole camp is powered by 3 electrical generators. The size, the 305, 103 is just the size of the tent. Don't fall asleep on me, okay? I'll wake you up again. So this is the schematic for the camp, and this This is the real picture. That was there in one exercise we did it in California. And here, this is the receiving tent, micro component, chemical, and the burning area. So let's talk about the protocol for receiving samples for testing. Very important, before a sample is received, there is what we call the EDO, or Explosive Devices Division. That division is responsible for screening any sample, any package for explosives. You do the initial screening for radiological, chemical agents first, before they bring it back to the receiving tent or here. So in this tent here, remember we talked about the private technician? There are two of them. One of them is going to question the customer or the person who's bringing the sample, collect as much as he can of information from him. The second one is going to screen the package just from the outside on to test or to screen for chemical and radiological agents. And they have the equipment and the instrument to do it. So once it's screened once it's screened here from outside, it's taken to the chemical component, and under the safety hood, they open up the package, and again screen for chemical and radiological agents from inside the package. They have the specific equipment to do so, and at the same time, if there is a presence of protein, which is synonym of presence of virus or bacteria, then you will bring it to microbiology for testing. Right? Question? Now, of course, we know the rules. Anytime you process sample, you have to observe the universal precautions, means that you treat all the samples as infectious, so you have to take your measures. You put your personal protective equipment, gloves, masks, goggles, and gowns, and you follow the SOP. It's very important. We don't care how competent you are to process samples, that's your job. My lab tech's job is to follow the SOP. When it says step 1, 2, 3, 4, 5, his job to do it. Not 1, 3, 5, and 4. No. Those are standardized and everyone knows this. And should be done under the safety cabinet, of course. So this is under the tent. You can see this is the safety cabinet, biosafety level 2 cabinet, and here that's where we process the samples before we're in there. For testing, we do what we call presumptive test, which is an initial test to tell you exactly what you're expecting. First of all, we have what we call the handheld assay. It's an immunoassay. It's based on antibody-antigen reaction. And it tests for 10 agents and 4 toxins. And here, you have to read it. This is a positive sample. This is a negative sample. And these two are invalid. Means there's something with your procedure or your kids. Once we have a positive sample, like here, then you move on for confirmation test. We use a very robust instrument. I don't think this instrument exists anywhere else because the company who makes it right now has a contract with the Department of Defense. Don't worry, it's not classified. C'est pas un secret pour nous. It's a ruggedized instrument, meaning called the JBA, Joint Biological Agent Identification and Diagnostic System. One most important aspect of this instrument is there is no refrigerated reagents. Everything is out. Lyophilized reagents. There is no restriction of cold chain or temperature here. And use the principle of real-time PCR. I'm not sure if you're familiar with real-time PCR, but this technique allows you to follow during the time the progress of your reaction. So we have some positives here in red and some negatives right here in green. Right now the panel can process or test for 4 FDA approved kits. One of them never. And of course for the other for the biochemical identification, we have the automated system. This is very famous, the DI system, and the microscan. This is the microscan right here. And you have the plate inoculated, you put it there and give you exactly which species you get. And the definitive confirmatory test is done in the US. This is those here, this is our reference lab for confirmation of biological warfare agent. At the CDC, US Amrit or US Army Medical Research Institute on Infectious Diseases, and we have the Naval Medical Research Center. And this is the chart summarizing the level of identification. So we have the presumptive level here in the field. We have our lab here for confirmatory and the definitive confirmatory tests are done at the CDC, US Amrit, and MRC. Of course, everything is shipped at 1 to 4 degrees Celsius according to the IATA regulation, the International Air Transport Association regulation. And this is an example of a culture. So we have a culture, and this is the special packaging that we use to ship it. Now, regulation, we talked about it this morning. We have what we call the biological select agent and toxin program. Any lab working on select agents must be registered under this program. And the CDC is the one leading this program. So for us, if we don't identify an agent, we have 7 days to destroy it, get rid of it. We are not allowed to store one of the agents at all. And everything must be documented. Of course, when you ship your isolate, there is custody form filled with all the information and the person responsible for it. Conclusion, the biotourism and the use of biological agents still a threat for both military and civilian population. Which we demonstrate that field diagnostics of biological BW agent demonstrate the benefit of state-of-the-art, comprehensive on-site diagnostic lab capability. Therefore, it should be considered as a necessity during public health emergencies and field operations. I think not only military but also Minister of Health should have this capability when there is an outbreak, should be dispatching a unit like that in the field in response to the outbreak. Alright, this is the picture taken of last exercise. This is my team. We had a lot of fun last time in California. It was very cold, you can tell. This is my email address right here. I'll be happy to receive any information or any comments, any questions, and I'll take you for your attention.